delete an item from heap. So the algorithm, we will just exchange the roots key with the last key of the heap. The first step says exchange. Sorry. Yeah, the algorithm says exchange the root key with the last key of the heap. Then decrease, once you delete an element, we have to decrease the size of heap also by 1. Isn't it? Once one element is gone, we have to decrease this heap. And then we have to, after exchanging, we have to heapify the smaller tree. You have deleted one element, hence becomes smaller tree. You have to heapify the smaller tree by shifting K down the tree exactly in the same way as it was done in your bottom up heap. Exactly the same way whatever it was done as in bottom up. Exactly the same way, however, it was done by using bottom up heap construction. Yes, let's see. Suppose we have a heap like this. 2, 5 and 1. Yeah. Whenever you are asked to delete an element from the heap, you will not ask the user to enter the element to be deleted from the heap, but because by default the element which will be deleted will be your root. Okay, that point you should remember. In a heap, whenever you are asked to delete an element, you will not ask the user which element to delete. That is because by default the element which will be deleted will be your root. So according to this, exchange the root key with the last key of the heap. That is, you have removed this, you have deleted this root. Now, which element should be replaced here? The last element. This is the last element here, isn't it? If we will consider this as array, 1 position, 2, 3, 4, 5, 6. This is your last element. So we have to exchange 1 and 9. That is, we are deleting 9 and we are in place of 9 we are putting 1. And then we'll decrease the size by 1. We usually what we do is we exchange first and then we will delete that 9. That is, decrease the size of heap by 1. How do we do it? I'll just show you here. So the first step I'm following, I'm exchanging the root key with the last key of the heap. So this is the last key, this is the last key, and this is your root. I'm exchanging those two according to this statement. So I have 1, 8, 6, 2, 5. Here I will get 9 because I have exchanged these two, isn't it? Root and the last key. What's the next step? Decrease the size of heap by 1, which means that the key will be deleted. This key will be deleted. So I'm deleting the last key here after swapping, which is 9. After that, my new tree will be 5. That's all, isn't it? Because I have deleted this. Now, step 2 is over. Decrease the size of key by 1. Now, heapify the smaller tree by shifting K down the tree by using bottom up heap construction. See here, this is the new key now. Check, it is a new key. It is smaller. Now I have to shift this down by using bottom up key approach. So how do I shift? First, it is compared with its children, isn't it? What do we do in bottom up heap? we will compare it with the children node. And if it is not having a parental dominance, we will shift down. So with which key I should exchange here? 1 should be exchanged with which key here?
8.
8 key. So I'll shift. I'm shifting. The next step is 8. I'll move it here. 1 here. 6 here. 2 here. And 5 here. Further I'll check, because that would be done until the key reaches the appropriate position. Now 1 in the new position we'll check with its children node. Is the parental dominance holding good here?
No, ma'am.
Yeah, with which I should exchange now?
1 and 5.
5.
Yes, 1 and 5, because with the larger child I will always exchange. So we will just exchange. So I'll write down that we should heapify. This procedure is called as heapify. The smaller tree until parental dominance is satisfied. So as parental dominance is missing here, I'm exchanging it and I will be getting 5, 6, 2, and here it is 1. Is the parental dominance holding good here?
Yes,
Is it
ma'am.
holding good?
Yes.
Do we have to move further? Or is this okay? Is this fine? Is the heap constructed properly?
Yes, ma'am.
Yes, this is how deletion happens. The same method we will use it for heap sort. Okay, this deleting the item method, if you will know, we will use this for your heap sort. Okay, so is it clear? Just note down this. We'll move on to heap sort now. All of you have attended the quiz yesterday. I didn't check. Did you receive the answer points? Hello?
Yes, ma'am.
You got the points?
Yes, ma'am.
Okay. I didn't check. I'll just check. Note on this. We'll move on to heap sort. Yeah, we'll move on. Is that over? Shall we move to the next topic, heap sort? And the last topic of this module.
Yes, ma'am.
Okay. Heap sort. So this heap sort is a two-stage algorithm. Okay, it's a two-stage algorithm. So stage 1, we will do the heap construction. Okay, heap construction will be done in stage 1. for the given array by using top-down approach. Okay, this is by using top-down heap construction we'll do. And the second step, stage 2, is called as maximum deletions. That is the same root deletion operation, whatever I just taught you, that we will do. So we will apply root deletion operation. N minus 1 times to the remaining heap. So what are the 2 steps we have in heap sort? Heap construction first we'll do, and then we'll apply maximum deletion. Okay. For the elements 2, 9, 7, same element, 6, 5, 8. We will just see how to perform heap sort with these 2 stages. Now, stage 1, heap construction, the same top-down approach. So how do we start? First element, then second step, 9. So we will insert 2, 9. Parental dominance is missing. We will exchange and we will get 9. 2. This you do by yourself because you know how to do it. With me only you should do it. 7. So I'm inserting 7 to the next vacant position. 7. Parental dominance is holding good. I'll move on to the next step. I'll try to insert 6. So 9, 2, 7. I'll insert 6 here. Here parental dominance is missing. I'll exchange these 2 because of parental dominance problem. And I will after exchanging, I will have 6 here, 7 and 2 over here. I'll move on to the next number, 5. What's the number? 5 again. So I'll try to insert 5 in the next vacant position. 6, 7, 2, 5 will be inserted here. Check for parental dominance. It holds good. Let's move on to inserting the next element, which is 8. So insert 8 to the already available heap. 6, 7, 2, 5, and I've inserted 8 here. Check for parental dominance. It's missing. I will exchange and I'll be getting the next. 1 second. Okay, so we have, after exchanging, we will get 2, 5 and 7. Again, we are checking here. So here again, parental dominance holds good. Parental dominance holds good. So we have this heap constructed. Let me write down the numbers now, in which order they are. So what, tell me the order in which I should write the numbers in array? Someone?
9, 6, 8, 2, 5, 7.
Yes. So it is 9, 6, 8, 2, 5, 7. Now we will apply maximum deletions for these elements and then we will sort it. Once you delete the element, you'll keep it in the last position. Once you look into the number at the end, it will be in sorted way. Okay. For deletions, we usually do that, isn't it? We'll exchange with the last element. We'll keep this in the last element. We will not remove it. We say we will remove that, and here when I said this, see heap, when we just deleted, we exchange with the last key and we placed it here and we'll forget this. That's all. We will not remove it. In array, you cannot just remove like that. It will be stored at the end. So last element will have the highest value. So among this, the next highest is 8. That has come to the root here. When I will delete that, that will be in the second last position. So when I finish all the deletions, I can get a sorted array, isn't it? That is what heap sort is. Understood? According to this, your last position is holding 9. When I apply the same deletion method for this tree, next element will be 8, which will be stored in the last but one position, isn't it? And next element will be 6, 5, 2, 1. The elements will be sorted after deleting all the elements from the tree, from the heap. So deletion is nothing but when you will delete the elements will be just sorted and placed in array. So only we are having that as stage 2, maximum deletions is the one which will give you the sorted array. Okay, we'll move and just show you how to do heap construction, you know very well. Even this maximum deletions also you have just gone through. So stage 2, maximum. They'll ask question like this only. Construct, do heap sort, perform heap sort by maximum deletions. Then don't get confused. It's nothing but the same. Okay, to maximum deletion. Now, this is your heap. This is your tree, isn't it? This is your tree. This is your final tree. Okay, that's your tree, whatever you constructed. Now, we should delete 9 by exchanging with 7. What is 7? It's the last key. That's how we will delete. Now, so I'll place this 7 here. So we will have 7 here in the root position. And then remaining elements as it is 6, 8, 2, 5 and this 9 we have exchanged with the last element. And to show that it is removed, I have put it is separated through this line. 9. I have shifted. I have exchanged root with the last key. And I have written 7, 6, 8, 2, 5. 9 I have removed and I have just shown it through through a line. So our new tree will be 7, 6, 8, 2, 5, isn't it? New tree 7, 6, 8, 2, 5. Now, parental dominant, we have to heapify this according to the deletion operation. We have to heapify this, isn't it? So after heapifying, so which are the keys which will be exchanged? Because there is no parental dominance over here. So we will just heapify this and we'll exchange. So we will have 8, 6, 7. We have exchanged these two. 2, 5. Let's check parental dominance. Yes, it holds good. Now, which is the element which we need to delete? Now, this is our new heap. Look into this and find out which element and by which element it should be replaced. Which is the last element here? Can someone tell me which is the last key here in this tree?
5, ma'am.
5, right. 5 is the last key. 0, 1, 2, 3, 4 or 1, 2, 3, 4, 5 last. We have to exchange 8 and 5. We'll do that here. The next step. Delete 8 by exchanging with 5, which is the last key. 8 is the root. Now, where do we get? So I have deleted 5, which means that 5 comes up to this position. Then we have 5, 6, 7, 2, 5, 6, 7, 2, and we have deleted 8. Okay. So already 9 is there. and we have deleted 8 now. You're getting, see, they are in order only, 9, 8. You can show that also here, the deleted elements 9 and 8. Right? Next, I just construct heap for this now. The new heap, we have 5, 6, 7 and 2. Is parental dominance holding good here for this new tree, whatever you have? These are the elements deleted. These are the elements existed.
No, ma'am.
Should I EPify? Should I EPify this tree?
Yes, ma'am.
Yeah. So
Yes,
I
ma'am.
should exchange with which element here now?
7.
7, because highest
5 and
value. 5 with 7. These two I should exchange. Now I will get 7 here, 6, 5 and 2. Is it a heap now? Yes, it is a heap because children node are smaller. Next step, the third step. Okay, third step. Now which is your root? 7. Delete 7 by exchanging with which key?
2.
What is the last key?
2.
Yes. So we will delete 7 by exchanging with 2, which is the last key. Now we will have, when we exchange, so 2 with 7, so 7 comes down, so 2 comes here. We will have 2, 6 and 5 as the element, and we will have 7, 8, 9 which are already deleted. To this side I have deleted elements. So what is my new tree? 2, 6 and 5. Isn't it? Check here only. 7 comes here, 2 goes there last. So we will have 2, 6, 5. We have written that. 2, 6, 5. Parental dominance. Parental dominance missing. We have to exchange with the larger element among the child. So these two will get exchanged. So I can have 6, 2 and 5. Parental dominance holds good? Yes. Write down next.